Consider the quadratic function, and they give it to us right over here. Find the x-intercepts of the function. And actually, I want you to find that and the y-intercept. All right, so let's start with the x-intercepts. This is when we are intersecting the x-axis, which is when the value of the function is going to be equal to 0, which means that this expression needs to be equal to 0. And if I have the product of two things equaling 0, then that means I can get to, that can be true when one or both of them is equal to 0. So this is going to happen if we have x plus 2 is equal to 0, or we have 3x minus 5 is equal to 0. X plus 2 is equal to 0. If I just subtract 2 from both sides, I get x is equal to negative 2. 3x minus 5 equals 0. I can add 5 to both sides. I get 3 equals 5. 3x equals 5. Divide both sides by 3, and I get x is equal to 5/3. So if x is equal to 5/3, it makes this part of the expression equal to 0. It will make the whole thing equal to 0. And if x equals negative 2, it makes this part of the expression equal to 0 and makes the whole thing 0. So the two coordinates where I'm intersecting the x-axis, it's going to be negative 2, and of course the y-coordinate is going to be 0, and x could be 5/3, and of course in that scenario as well, the y-coordinate is going to be 0. Now if we wanted to think about y-intercepts, y-intercept, that's where we are intersecting the y-axis. So that's when x is equal to 0. Well, if we want to figure out when x equals 0, we can just evaluate f of 0. f of 0 is going to be equal to 0 plus 2, which is 2, times 3 times 0 is 0, minus 5 is negative 5. So it's 2 times negative 5, which is equal to negative 10. And so the y-intercept is going to be x equals 0, and y is equal to negative 10. And we're done. We have figured out the x-intercepts and the y-intercept.